In this video, we're going to look at the law of cosines. This is going to build on our knowledge of the law of sines and allow us to solve all triangles that are not right triangles. So we already knew how to solve right triangles. Law of sines allowed us to solve certain types of triangles that were not right triangles. We had to have that known pairing that the two sides across from one another. Law of cosines will allow me to solve other cases when we don't have the known pairing. And so it is important to note that we can't use law of sines to solve every non-right triangle. We can't use the law of cosines to solve every non-right triangle. We do need to have both skills. So we're defining everything the same way. A, B, and C lowercase still there, the sides, and then they have the respective opposite angles of uppercase A, B, and C. Then a squared equals b squared plus c squared minus 2bc cosine A. B squared equals a squared plus c squared minus 2ac cosine B. C squared equals a squared plus b squared minus 2ab cosine C. I do expect you to know the formulas for the law of sines and cosines. Now this looks like three formulas, but really keep in mind it's one. They're all the same. They're all identical. We're just switching around the letters. The key to remember is whatever side we are looking for, whatever side is on its own side, we are looking at the angle with that, and then the other two sides are the ones that we're squaring. If we dropped off that minus 2bc cosine A part, that would look very similar to the Pythagorean theorem. That's not just by chance. We would see that in the proof. And so this is another video. I'm not going to do the proof in. I want to just concentrate on the examples and using it, but do look at the proof and you're going to see this makes a lot of sense. There's a correction factor here because it is a non-right triangle, but we do need the Pythagorean theorem to build this formula. So again, they are really all the same formula. It's just a matter of where the pieces are, and it really doesn't matter what we name the pieces, and that's why they're all the same. So let's solve the triangle with sides A equal to 13, B is equal to 16, and angle A, let's do angle C rather. I need it to be the non-matching pairing. Angle C is equal to 58. Just like I did with my law of sines, I'm going to start with the picture. Now the nice thing about the law of cosines is it's not going to be as ambiguous. It's not going to have those weird cases where there's one or two or no solutions. There's either going to be one or none. There's always a possibility of math that things just don't work out, that we've created an impossible triangle. One side's way too much longer than another. That is always a possibility. But there is no two solutions here that we're going to need to worry about. The reason I'm still telling you to draw it out first is it is still important to know that we have the order correct. We can't always know from the start that the order is going to be a certain way. But we can make some guesses. We know that the A is less than the B. That is clear. So I'm going to put the 16 over here. I know the A is smaller. And I'm kind of trying to think to myself now, is the B supposed to be the biggest or is it the C? I haven't really made my picture very clear either. I've tried to draw them similar because I'm not 100% sure, but let's think about it for a minute. So we know that A is less than the other two, right? It's less than the B. Right now we have one angle of 58 degrees, which means that the other two angles in total have to add to 122 degrees. If we're to split them evenly, then we would have 61 degrees apiece, which is bigger than the 58. So we know it's not an even split, they're not the same number, but even if it was an even split, that B would have to be larger than the C. So I do know at this point that angle B will be the biggest. I know that B is the biggest, pretty sure C is next, and then A would be the smallest because I don't think it's an even split on the 62. But I know what the largest one is, and so that's going to remove that problem that we had with the law of sines of, do I use this angle or do I use its reference angle in the second quadrant? So we'll talk more about that as we go forward. It is important to note the order of the triangle. Anytime you start off with the law of sines, if you're starting the problem with the law of cosines rather, there is a guaranteed order that you just need to figure out. There will never be two solutions, so you need to make sure you have that order set correctly. Let's get to the math. We want to solve the triangle, which means I want to know all the pieces. There's only one piece right now that I can solve for, and that is side C. I only have angle C, and so if I look back at my law of cosines, angle C means I have to be getting to a side C, and conveniently enough, I have the A and the B too. I could not use law of law of sines here. So we'll have c squared equals 13 squared plus 16 squared minus 2 times 13 times 16 times cosine of 58 degrees. Now I'm going to essentially just type all this in the calculator, and then I also have to remember to take the square root of both sides. And so I'm going to do that all in one step. So when I do that, put it into my calculator and solve, I should get c to be 14.302 or 30. 14.3 units. Again, I haven't labeled my units here. Whatever my units would be, I'd use those. So using my law of cosines, I see that 14 is exactly dead in the middle of 13 and 16. So those assumptions I made at the start are exactly right. I know that I've correctly placed that 14.3. Now I have a lot more options available to me. I could use the law of cosines to solve for that next angle if I wanted to. But I think this formula is a little bit longer, a little bit more complex than the law of sines, takes a little bit more work. So I'm just going to switch back over to the law of sines because I know what this angle is supposed to be. Now, I don't know what the largest angle is. I know that the largest angle is supposed to be B, but I don't know what that number is. So we saw before when we used the law of sines, we potentially got the wrong angle out of it. We had one of two possibilities. We've said on this problem there can only be one solution. I don't want to run into that possibility of are we supposed to be using the other answer or is this initial answer correct? So when I use the law of sines, I'm always going to use the law of sines to find my smallest angle, which is the 13. So I'm going to set it up with the angles on top, sine of 14, sine of 58, sine of the 58 over the, get my eraser working here, just cross all this out, try it again, my tablet's frozen here, sine of the 58 over angle C was 58, the side was the 14.3 that we just found. I'm looking for the smallest angle, which is angle A. We knew that the related side was 13. So to solve for A, I'd multiply by the 13 and I have to take the inverse sine. And 14.3 still on the bottom. And that's not a degree. When I type this into the calculator, I get the answer of 50.43 degrees. So there's my angle A. Notice it is smaller than angle C. I still need to find angle B. And so to do this, the easiest way to do it is 180 minus the 50.43 minus my angle C, which was 58. When we subtract all those things, I get the approximate answer of 71.57. So notice, angle B was the acute angle. If right here when I did the law of sines, if I'd instead set this up with the sine B, I would have gotten the right answer. Sine B over the 15. If I'd solved this, and just checking to make sure I had 16, not 15. If I'd solved this with the 16, I would have gotten B to be 71.57 directly. That would have been the right answer. I would have been complete, but I wouldn't have known that. I wouldn't have known that off the start, and that was the problem. That's why I tried to avoid using the law of sines for the smallest angle. Now, this next one that we're going to do is a side-side-side problem, as opposed to the side angle side that we just saw. A is equal to 9.2, B is equal to 5.1, and then C is equal to 11.3. We have the three sides here. When I have three sides, I know exactly how that ordering falls. I can clearly see that C is bigger than A, that is bigger than B. I know exactly the order that they are going to take. I can draw that out. I would see the same thing. So 11.3, angle C will be the biggest. B, 5.1 will be the smallest side. And then angle A will be the middle at the 9.2. I know exactly how they're going to fall, and so it makes the thinking about it a little bit easier. But what I have to keep in mind is if I'm going to start with law of cosines, and I have all three sides, I always want to find the largest side first. Let me write that out. When solving using law of cosines, find largest angle first. I'm going to add the addendum when possible. And why did I add that when possible? Well, if we look at the first case, we couldn't find that largest angle, right? If we were to look at that problem, the first thing we had to find was C. That was our only option there. So we would have loved to have found angle B first. We knew it was the largest, we just couldn't do it. So we're going to find that largest side using law of cosines first when possible. If not possible, if we can't, always find the smallest angle with the law of sines. So that's what we did in the first case. That's what we talked through. That's why I chose to start with A first. That way I avoided the ambiguity of the law of cosines with B. But here, because I have all three sides, it doesn't matter which angle I want to find first, except for that rule that I just defined. I can find any of the three angles first, so I might as well find C first. Now, the formula doesn't solve that directly. We're going to have to do a little bit of math. We're going to have to do a little bit of algebra. Let me set it up. So we have our C squared equals A squared plus B squared minus 2 times my A times my B. Get rid of that. Times the cosine of angle C, which we don't know. I need to solve this for the cosine C, so we're going to have to do some rearranging. I'm not going to bother to type anything into the calculator yet. I'm going to keep everything as exact values. I'm going to avoid typing things into the calculator. First thing I'm going to do is subtract these over to the other side. So now I have left the negative 2 times 9.2 times 5.1 cosine C. And then to completely isolate the cosine C, I'm going to have to divide that left-hand side by the negative 2 times 9.2 times 5.1. I see a lot of algebraic errors in this section. I see a lot of people just try to add all of these things together right away. Square that, subtract that, add it all together right away. Well, we can't do that because multiplication has to come first. So I have to move these away first through subtraction, then I can divide off. And then the final thing I'm going to do to get C by itself is take the inverse cosine of that big long expression. And so when I type that into the calculator, it is an approximate, I get approximately 100.46 degrees. And so by using the law of cosines, I guarantee I have the right one. Now wait a minute, when we were using the inverse cosine, didn't that give us one of two possibilities? Yes, it did. But where was the second possibility? Is in the fourth quadrant, right? If it's a negative, it's going to be in the fourth quadrant. Well, it's impossible that we're going to have, I said that wrong. If it was a positive ratio of sides, which we have here, and we're taking the inverse cosine, is in the first or is in the fourth quadrant. But it's impossible to be in the fourth quadrant because the angles of a triangle can only be between 0 and 180. The fourth quadrant is larger than 180. So by using law of cosines, I guarantee myself I have that answer right. There's no second possibility there. That's the reason I want to start with that law of cosines. If I'd started with a different angle, I wouldn't know exactly that I was going to have the right C by the end of it. So I want to make sure I'm finding that largest angle with law of cosines. All right, next thing I need to do is find another one of the angles, either A or C. At this point, it doesn't matter. I always default to the law of sines with my smallest. So I'm going to use what was my smallest? 5.1, the B, not the A, but the 5.1. I'm going to default to the smallest for my law of sines. I set it up with my angles on top. And my side for C was 11.3. I'm looking for angle B because side B of 5.1 was my smallest. And so then to get B by itself, we would take the inverse sine of 5.1 times sine 100.46 over 11.3. And when we type all this into the calculator, we'll get the approximated value of 26.35. And so there's my angle B. And then last, to find the final angle, easiest thing to do, subtract from 180. And the C we had found was 100.46. So we subtract these, we get an A value of approximately 53.19. And so now we have all three angles, we have the three sides. Because we made sure we went through and determined the order first, we know we have all of those correct. We know we have the correct order. Law of cosines, a little bit more work in terms of the formula, but it's a little bit nicer because we only have the one solution. Or again, there might be cases where we have no solutions, but we'd work it out and just the math would break. We'd have a domain error, we'd have that undetermined value.